Okay, 2020 Specialist Paper 2 Tech Active. This is doing question 18. Stats question. Mass of a certain species of kangaroos is known to be normally distributed with a mass mu, standard deviation. When one of the kangaroos is randomly selected from the probability, its mass is greater than 83.2, is 0.1. Sorry, I read that really poorly, didn't I? Is greater than 83.2 is 0.145. When a sample of 12 kangaroos is randomly selected, the probability that the sample mean mass is less than 74.1 is 0.079. A 90% confidence interval for mu is calculated using a random sample of n kangaroos that has a sample mean mass of 79.1 and a sample standard deviation equal to mu. Determine the possible values of n that could be given the confidence interval did not contain mu. Wow, there's a lot going on here. It's a very wordy question. Let's take it from our first one. We know that it is being normally distributed. So we know mu is here. We know that the probability of the mass is greater than 83.2. This bit, this area is 0.145. Okay, so let's put this as a z-score. Now, first off, what would the z-score be? Let's go into our stats mode. Cross into stats mode. Now, I want to find the z-score, so I'm going to go distribution, normal, inverse n. I want the tail right. I want the area to be 0.145. What if the standard deviation 1 and a mean of 0 in the middle? So the equivalent z-score of this is 1.058. So in my regular z-score, z equals x bar, or the number, so z equals 83.2, take mu over that. So 1.058, sorry, is 83.2, take the mean over the standard deviation. We're going to have a series of equations we're going to find using the different bits of information, and then hopefully it'll all come together in the end. Now, from the second one here, we've got n, our sample, n equals 12. The probability that the sample mean mass is less than 74.1 is that. So let's look at that as a diagram, because we know it's all normally distributed. 74.1, and this at the end is 0.079. So what would this be as a z-score? So I'm going to exit back out. I'm going to make this a tail left. Oh man, exit, sorry. And it was 0.079 this time. So that gives me negative 1.412. So going over here now, normally we'd go z equals 74.1, take mu, oops, because it's a sample over our standard deviation changes. Sorry, my camera work's not great today. So negative 1.412 is 74.1 take mu over square root of 12. Now we have two simultaneous equations with two unknowns. Okay. How are we going to find these? What would be the easiest way? If I call this 1 and I call this 2, if I rearrange 1.058 mu equals, phi, take mu equals 83.2, take 1.058, there we go. And if I take the second one, again, I'm just trying to rearrange it so that it's mu. So that's, I want it rearranged like that. Now if I rearrange the second one, it's negative 1.412 mu over square root of 12, 74.1 take mu. I'm going to write outside the box, which I know you should not do in an exam, but I bring that over here, 74.1 plus 1.412 over square root of 12. We need to solve these. We could solve them algebraically, couldn't we? We all have those skills. But what would be the easiest way for us to solve them? Using our graphic calculator. I know we could probably use your simultaneous equations. The way I'm going to do it is I'm going to graph. So I'm going to go menu, graph. Excuse me while I just delete my graphs that I've got in there. So if I go in here and I go 83.2, take 1.058, delete 58, and call that my x. And my second one is 74.1 plus 1.412 over square root of 12. And I'm going to put my x, so I've just graphed them. Draw. I think I just need to improve my window. Next go negative 50. Oops, delete. And let's go down here. I'm going to make my y to 100. See where we go. What's that going to look like? Okay, now I want to G-solve, intersect. Okay, so therefore, I've graphed, G-solve, and remember my x is my phi equals 6.209, and my mu equals 76.63. Okay, so there I've found them there. That was a big part of what we had to do. What do we have to do next? What's the next step? All right. A 90% confidence interval is calculated using a random sample of n kangaroos and the sample mean mass of 79.1 and a sample standard deviation equal to. Determine the possible range in values of n that it could be. Okay, so let's go using our third thing. I'm a rewriter, so I'm a 90% CU, or CI, confidence interval. I don't know n, that's what I'm trying to find. The sample mean mass is 79.1. The standard deviation is the same, so that's 6.21, because I'll just go 2 decimal places. Determine the possible range in values of n could have, given that the confidence interval does not contain mu. So does not contain 76.63. That's where we're going with that, because that's our mu. So in our normal distribution, .63 is our lower bond, mu, because this is mu not in Ci, so we're going to say it's our lower band. So we're going to go that our lower band of it is, minus Z over square root of N. That's our lower band. So 79.1 take 1.64, because it's a 90% confidence interval, gives us 1.64 times 6.21 over square root of N has got to equal 76.63. So let's jump back to our run mat mode and we can solve in it. Options, calc, solve n, 79.1, take 1.64, sorry, can you see that? Times 6.21 over shift square root of my x, shift equals 76.63, close brackets, exit, and we get n equals 17.00109. This is our exact bond, so therefore n has got to be bigger than or equal to 18, because we don't want to actually include the 76.63, so we'll get to there. That's that one.